arranges elements based on their priority values. Elements with higher priority values are typically retrieved before elements with lower priority values. So, ang priority queue is, muna siya ang ga-arrange sa mga values. I-arrange sa niya ang mga values o sa siya mo execute. Then, so ang priority value, if it is descending, it start with highest value. And if it is ascending, it start with lowest value. Unlike siya sa queue kay ang queue, kung unsa to ang muuna nga musulod nga value mo ang muuna og gawas. So or ma-implement siya og first in first out. Then sa priority queue is iya sang i-arrange ang iyang elements. So sa ascending priority queue, if the item with the smallest key has the highest priority. That means delete the smallest element always. Similarly, a priority queue is said to be descending priority queue if the item with the largest key has the highest priority, or delete the maximum element always. Ang pag-insert nato sa priority queue, ang dili natin ipanin, ang dili na iyang sulutan sa iyang mga values, and then delete max. So, ang example ani is kani, ang iyang value is ascending order. Kaya sugod siya sa dako, paingon siya sa gamay. Then, ang gamay ani mo yung una o remove, then in priority queue, we have operations on priority queue. Mainly, the following three basic operations of priority queue are: first, insert key data. Insert data with key to the priority queue. Elements are ordered based on key. Delete min or delete max. Remove and return the element with the smallest or largest key. Next is get minimum and get maximum. Return the element with the smallest or largest key without deleting it. So the basic features of priority queues are: each item has some priority associated with it. An item with the highest priority is moved at the front and deleted first. And then, if two elements share the same value, then the priority queue follows the first in, first out principle for the queue operation. Next is application of priority queue. Priority queue are used to select the next process to run, ensuring high priority tasks run before low priority ones. It is also applied for load balancing and interrupt handling. A few of them are listed below. So first is data compression, Huffman coding algorithm. Second is shortest path algorithm, DJ Strass algorithm. Third is minimum spanning tree algorithms, Prim's algorithm. Fourth is event-driven simulation, customers in a line. And fifth is selection problem, finding the smallest or largest element.
So I am the second reporter. My topic is all about implementation of priority queue data structure. Priority queue can be implemented using an array, unlike less in a heap data structure or binary search tree. Among these data structures, heap data structure provides an efficient when elements are inserted into the array without bothering about the others. Deletion of delete max are performed by searching the K and others deletion. Then deleting insertion complexity quantity 1 or delete main complexity n. So ang delete main is we can easily to find values to return and the top of heap unfortunately removed leaves a vacuum that must be filled by someone other element. Then it is very similar to array implementation, but instead of using array, linked lists are used. Ins- Insertion, complexity, quantity 1, delayment, complexity, and when elements are inserted into the array, in short order based on the K-field, deletion are performed on only one end. Insert, Insertion, complexity, quantity 1, delayment, complexity, and elements are inserted into the list in shorted order based on a K-field. Deletion are performed on only one end, hence preserving the status of the priority queue. All other functionalities associated with the linked list ADT are performed without modification, insert complicity, and delayment complicity. Okay, mo ni siya kuan. Yang kuan insertation, deletion, delete or delete max, finding. Heaps and binary heaps. Heaps is a tree some special properties. The basic requirement of a heap is that the value of the node must be greater than or less than the value is of each children. This is called heap property, and heap also the additional property that lib should be at h or h minus 1 level, where h is the highest level of the tree. For some h greater than 0, complete binary trees means heap should from the complete binary trees. So additional sa heaps is a complete binary tree based data structure. You should have a good understanding of the trees before jumping to this section. Heap has specific order properties. The ordering can be one of two types. So, ang heaps is na siya two types. So, mo din siya kanang example of one. In the example below, the left tree is the heaps. Each element is greater than its children, and the right tree is not heap, since 11 is greater than 12 too. So, ang two types of heaps is main heap. Main heap is the value of node must be less than or equal to the value of its children. So kay ang iyang pinakagamay is naa sa root, di mo na siyang kuan kanang less than. So ang iyang kukuanan na is the value of each node is greater than or equal to the value of its parent. The smallest value is a root. The same property must be turned true for all subtrays. So muna siya din. Ang sa maximum naman is the value of a node must be greater than or equal to the value of its children. So ang iyang pinakadako ang mo sa root. So ang maximum is the value of each node is less than or equal to the value of the parent. Ang greatest value is the root. So muna siya ang pinakadako na sa root. Then the same property must be true of all subtrays. Then the binary heaps. The binary heaps is a complete binary tree which satisfies the heaps ordering property. In binary heaps, each node may have up to 2 children. So, representing heaps. Before looking at heaps operation, let us see how heaps can be represented. One possibility is using arrays. Since heaps is forming complete binary trees, there is not be any wastage of location. So inani siya forma gikan sa 0 paingon sa 6.
Hi everyone, I'm Eduardo Canilargo Jr., the third reporter. The main topic, priority keys and heaps data structure. My assigned topic is priority keys heaps problems and solution. Problem 1. Is there a main heap with 7 distinct elements so that the pre-order traversal of it gives the elements in a sorted order? Solution: yes. For the 3 below, pre-order acceding order. The root is 1, then follow the right side 2, 3 and 4, then the left side 5, 6 and 7. In problem 2, is there a max heaps given with the 7 distinct elements so that the pre-order traversal of it gives the elements in a sorted order? Solution: yes. For the 3 below, pre-order traversal produce descending order. So the root is 7, then the right side is 6, down to 5 and 4, then the left side is 3, down to 2 and 1. In problem 3, is there a main heap, max heap, with 7 distinct elements so that the post-order traversal of it gives the elements in a sorted order? Solution: yes. If the tree is a max heap and we are descending order below left, or if the tree is a main heap and we want the first diagram, this is the example of the max heap. The root is 7, then in the left side 6, 5 and 4, then in the right side 3, 2 and 1. In the second diagram, this example of the main heap, the root is 1, then in the left side is 2, 3 and 4, then in the right side 5 down to 6 and 7. In summary, binary heap is a data structure that is specialized tree-based implementation of the binary search tree, and it follows the heap property. It used to implement according to a specific criterion, such as the priority of the elements, the time complexity of certain operations like inserting and deleting elements in a binary heap,